Okay, how's it, Chase? Today we're going to start on chapter 5, which is sketching graphs. It's a very long chapter, but yeah, it's actually quite a nice one, I think, once you get into it. So it's chapter 5, sketching graphs. Okay, so they start off by describing the rectangular system of axes. So basically that's just your regular Cartesian plane, and you know the basics of the Cartesian plane. You've got an x-axis and a y-axis. The y-axis is your vertical line, your x-axis is your horizontal line. The Cartesian plane is divided into 4 quadrants. 1, 2, 3, 4. Okay, those are the quadrants of your Cartesian plane. And this point here, the 0 point on the x and y axis, is known as the origin. Okay, so that is the origin. Okay. Next, they're going to talk about ordered pairs. Okay. So, ordered pairs. Okay. Ordered pairs represent a point on the x and y axis. So the ordered pairs are presented like this. Okay, and you'll have 2 numbers A and B here, and with the semicolon separating them. So that is the first number in ordered pairs, your x coordinate, and that is your y coordinate. Okay, so let's just plot a couple of ordered pairs on a Cartesian plane. 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, 4. Negative 2, negative 3, negative 4. That's our x-axis and our y-axis. Don't forget your arrows. So I'm just going to mark 1 to 4. 1 and 4. You should mark each of these points when you draw this, but just for saving some time, I'm just going to mark these points. Negative 1, negative 4. Okay, so let's just draw these ordered pairs. I'm going to call this ordered pair A. Okay, and that's the name of the ordered pair. That number or that letter outside the ordered pair. C and D. Okay. So we'll draw 0 and 4, 1 and negative 2, 4 and negative 4, negative 4, negative 4. Okay, so A, remember we said x coordinate, y coordinate. So we started A, the x coordinate, so we've got 0 on the x-axis and 4 on the y-axis. So here's 0, we go up to 4 on the y-axis, and there is point A. Okay. Point B, 1 and negative 2. So go to 1 on the x-axis, negative 2 on the y-axis. That's point B. Point C, 4 on the x-axis, negative 4 on the y-axis. So that sits over there. That's point C. Point D, negative 4 on the x-axis, negative 4 on the y-axis. So go to the x-axis, minus 4, y-axis, minus 4, and that is point D over there. Okay? So now, given where we've plotted the points, let's check what quadrant they're in. Remember, here's our quadrant labels. So point A lies on the vertical axis, so that can either be quadrant, so I'm just going to mark it quadrant. It's going to be either quadrant 1 or 2. Okay. Point B, let's go look where that lies. You can see that is quadrant 4. Quadrant 4. Point C is negative 4, negative 4, and that is also quadrant 4. Point D is lying over here, which is quadrant 3. Okay. Next we're going to talk about domain and range. Okay, so domain and range. Okay. Okay, so domain and range represent, okay, so let's start with domain. This is the points which contain all x coordinates of the ordered pair. Okay, and range is the same, except it's the points which contain all the y coordinates of the ordered pairs. Okay, so let's determine the domain and range of these points that we drew here. Let's look at the domain. Okay, so can you see that from negative 4, if we look at all of our points, they lie between negative 4 all the way up to 4. Can you see that? Okay. And our range, the points lie, they start at negative 4 on the y-axis, and they go all the way up to positive 4 on the y-axis. Okay. So for our ordered pairs, it's very simple. Basically, the domain, we just write out all of the x points that exist. So all of our domain is in this color. So we write out all of our x points here. And for the range, we're going to write out all of our x points here, or all of our y points, okay, in ascending order. So the domain here of this set of ordered pairs, the domain is, domain is, we use curly brackets, okay, what's our lowest x point? Because we need to write in ascending order, it's negative 4. So the domain is negative 4. Our next lowest x point is 0. Then we've got 1 and 4. See that? Negative 4, 0, 1, 4. Then for our range, we've got negative 4, negative 4, negative 2, and 4. And there you go. There's your domain and range of this set of ordered pairs over here. Okay, the next section talks about relations, and so a relation, let's get white here, relation okay, is basically a formula which relates x and y components of an ordered pair. Stated otherwise, a formula or a function can generate sets of ordered pairs. So the example they gave in your book here is y equals 3x plus 6. Now, in these formulas, you've got a dependent and an independent variable. Okay? So, that's dependent and that is independent. Okay. So, the independent variable is the number that we insert into the formula in order to generate a dependent variable. So basically here, y is dependent on the value of x. And x we can select freely in order to generate the dependent y. So, let's generate a couple of ordered pairs. So, let's make a few here. Okay, let's do 3. So, let's select some independent variables and let's see what they did in your book. Okay, the independent variables they selected in your book were 0, 1, and 2. 0, 1, and 2. So if we plug in these values for x, we get 3 times 0 plus 6. Then for the second ordered pair, we get 3 times 1 plus 6. And for the third ordered pair, we get 3 times 2 plus 6. And these generate the dependent variables. So let's calculate. 3 times 0 is 0 plus 6 is 6. 3 times 1 is 3 plus 6 is 9. 3 times 2 is 6 plus 6 is 12. And there you go. Your independent variables generated dependent variables by plugging them into the formula. And that's the idea of a relation. Okay, so next in your book we've got an example here. Let me just give us a blank page here. Okay. Next up in your book we have an example. And that is example 4. Example 4. Sketch the relation. And a relation is just another term for a function, basically, which is what you'll probably know it as. Sketch the relation y equals root x. Okay. Then they say, to make it easy, select dependent variables, i.e. x values, with easy square roots. Okay? So numbers with easy square roots are 1, 4, 9. It's all your square numbers. 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared is 16. Okay? Alright, so let's plug in our dependent variables, which we've selected here. So these are all x values slash dependent variables. We plug them into this relation or function and get the corresponding y values. Okay, so let's plug them in. So y equals root 1, which is equal to plus or minus 1. Y equals root 4, which is equal to plus or minus 2. Y equals root 9, which is equal to plus minus 3. Y equals root 16, which is equal to plus or minus 4. Okay. You may be wondering where the plus minus story comes from. So the plus minus happens whenever there's a square root, because let's look at it this way. If I tell you the square root of 1 squared, you know that the square cancels with the square root and it's equal to 1. But what if I tell you the square root of minus 1 squared? That is equal to minus 1. But do you agree that negative 1 squared is equal to minus 1 times minus 1 is equal to 1? Okay. So these two brackets, 1 squared is equal to negative 1 squared. So when we say the square root of 1, we don't know whether it's the square root of 1 squared or the square root of minus 1 squared. It could be either. That's why our answer is plus minus 1. Okay, and the same follows for all of these. Alright, so now it's interesting because our dependent variables, okay, let's write out our set of ordered pairs. Okay, 2, 3, 4. Okay, our dependent variables were over here 1, I'm going to do that in red, 1, 4, 9, 16. So then ask yourself, what y value did x equals 1 generate, or the dependent variable of 1 generate? That value, you plug it into our relation or our function, and we get the square root of 1 equals plus minus 1. So that's where it gets interesting, because now one dependent variable has generated one independent variable, sorry, these are independent. One independent variable has generated 2 dependent variables. Those are plus 1 and minus 1. Okay, so we actually need two sets of ordered pairs for each independent variable. So let's draw those out. And okay, put that in. Okay. And we're going to put the same independent variables here, 1, 4, 9, 16. Okay, so independent variable 1 generated plus 1 and minus 1 when plugged into the formula or the relation. Independent variable 4 generated plus or minus 2. Independent variable 9 gave plus 3 and minus 3. And 16 gave plus 4 and minus 4. You need to be careful. If you plot this in your calculator, I'm actually going to do it right now and double check it with you. But I believe if you plot this in your calculator, if you plot this particular function in your calculator, you will only end up with the positive values and not the negative values. So you need to be very careful of that. Calculator will only give you this set of ordered pairs, but it won't give you this set. So be careful. Sometimes the calculator is not always 100% right. It only gives you a half answer. Okay. So we've worked out our set of ordered pairs that were generated with our relation. And the instruction was to sketch the relation y equals root x. So now we've got a bunch of ordered pairs. So if we draw them in on a Cartesian plane and connect the line between all the points, we will have sketched it. So let's do it quickly. Let's draw our Cartesian plane here. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, so that is the origin, 0. 1 to 4, minus 1 to minus 4, and 1 to 9. I'm not going to use this last ordered pair because it's just too much to draw in. Okay, remember, label your axes, x and y, and remember to label each of these points, don't be lazy like me. Okay, so let's start sketching our ordered pairs. We've got x equals 1 and y equals plus 1 and minus 1. So let's draw both of those ordered pairs. So we'll draw this one first, 1 and 1. And then we've got 1 on the x and minus 1 on the y, which is this point here. Then we've got 4 and 2 and 4 and negative 2. So let's go to x equals 4, 2, 3, 4. And it is 2 and minus 2. Then we've got 9 and plus 3 and 9 and minus 3. So go to x equals 9, and we've got 3 and minus 3. There we go. We've sketched all of our ordered, well, we've drawn in our ordered pairs. One that we forgot to do is 0. Okay? If we plug in x equals 0, the square root of 0 is 0. And there's no such thing as plus minus 0. You can just have 0. So that actually is this point over there. And then we just draw a line in between our dots. Okay? And there we go. That line is the line y equals root x. So now you've sketched your relation or your function, and you have you've sketched it and you've answered your question, and that's it. Okay. So I've spoken about the term relation and function quite interchangeably so far. Okay, so I've used the term function and relation quite interchangeably so far, but there is actually a difference. So what's the difference between a function and a relation? Okay, so functions Okay, so a function has one y point for each x point, or one dependent variable for each independent variable. A relation has multiple y points or dependent variables for each x point or independent variable. So if we look at this relation here, you see that we had one dependent variable, and when we plugged it in, or one independent variable, we plug it into the relation and we get two y points or two dependent variables, which means that y equals root x is a relation and not a function. Okay. The easy way to test this is with what they call the ruler test. If you hold a ruler parallel to the y-axis, okay, and at any point, so you draw vertical lines, okay, if the sketch crosses vertical line more than one time, it is a relation. If sketch crosses once only, it is a function. Okay, so you can see, and of all the vertical lines you draw, it only has to cross, if it crosses any vertical line more than once, it's a relation and not a function. So you can see here with the graph, it crosses the vertical line twice over there, and twice over there, twice over there. So it's definitely a relation and not a function. Okay. Okay, so the next thing that the book talks about is functions. Okay, let's get white pen here. Functions. Functions. So a function is a special type of relation, i.e. all functions are relations, but not all relations are functions. Okay. So if you've got your set of, here's the world of relations, and functions is a little piece, a little set inside of that. Okay. So the notation for a function is f of x. Okay. So for relations, you can have y equals, as you saw with our previous stuff that we just did there, y equals root x, and then we've got y equals plus minus 2. Okay, where a function, the notation is f of x, but because a function is also a relation, we can write y equals f of x equals, for example, 2x plus 3. Okay, except because it's a function, we will only ever have one y value for each x value. Okay. So let's do they've got a little example here. Sketch f of x equals x plus 2. So once again, choose any x values here because they don't tell you for which x values you must sketch f of x, so you can choose any. So let's choose x equals, and we draw the set 0, 1, 2, 3. Okay, so we're going to plug in these independent variables in for x, and we're going to get the values of the function of f of x. So f of x equals x plus 2, f of 0 equals 0 plus 2, f of 1 equals 1 plus 2, f of 2 equals 2 plus 2, f of 3 equals 3 plus 2. You see, we just plugged in these independent variables into there. Okay. And the notation, we also show what independent variable we're plugging in by putting it in the brackets here by the f. So f of 0 means substitute 0 where you see an x. Okay. Right, so let's just get the final values here. We've got 2, 3, 4, and 5. Which gives us a bunch of ordered pairs as well. Because we've got x equals 0 and f of x equals 2. So 0 and 2. Remember, f of x is the same as y. F of 1 equals 3. So x is 1, y is 3. X is 2, y is 4. X is 3, y is 5. Okay. So now we can sketch that function on a Cartesian plane. So let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 5. That is our x and that is our y. So let's sketch our ordered pairs there. X is 0, y is 2. So 0 and 2. 1 and 3. 1 and 3. 2 and 4. So x is 2, y is 4. Oops, did I make it? No. Okay, and 3 and 5. X is 3, y is 5. And then we can just draw a line between them. And there you go, you've sketched your graph. Or sketched your function. Okay, let me open a new one for us. Nice blank page. Okay. So on the next page in your book, they give a definition of a function, which is basically the same as what I've already told you. A function is a prescription or relation according to which each element of the first set is associated with one element in the second set. What they mean by that is for each x value, you only have one y value, i.e. for each independent variable, you only have one dependent variable. And then they give an example of the vertical line test, which is as I explained earlier. So they drew a couple of graphs here. Here's a sine or a cos graph. Here they've got a square root of x graph. And here they've got a graph of tan. Okay, they drew tan there. Could be tan, it could be the hyperbolic function. Actually, I'm not sure. I think it's the hyperbolic function that they drew there. Doesn't matter. Okay, so let's do the vertical. And basically the question here would be, are these relations or functions? So how we're going to determine that is the vertical line test. So let's start drawing our vertical lines. Let's do them in a different color actually. Draw the vertical lines. Okay. Now if we look at the first one, you see that there's one crossing on that line, one there, one there, one there. So there's only one y value for each x value, which means it is a function. Here we've got, on this line, we've got two crossings, which means it is a relation. Because there are more than the line or the sketch crosses the vertical line more than once, so it's a relation, i.e. there are two y values for each x value, relation. Here there's no crossing, you've got a crossing there on that line, one crossing there, one crossing there. It never crosses any vertical line more than twice, therefore it is a function. Okay. Okay, so the next section talks about continuous and discontinuous functions. So continuous and discontinuous functions. Okay, so basically, if a function can be drawn without lifting your hand or without lifting your pen, it is continuous. If you have to lift your hand or lift your pen at any point, then the function is discontinuous. So let's look at the same three functions that I drew earlier and see if they're continuous or discontinuous. Okay, so there's 1, 2, 3. So let's start sketching them. So the first one looked something like this. You notice how I never had to lift my pen. It just flows, the line just flows. Okay, so it is continuous. Okay, let's draw the second one, which looked something like this. Once again, you don't have to lift your pen to draw it. So it is continuous. Then let's look at the third one. That one had an asymptote here at 90 degrees. Okay. And let's draw that one. Notice how I had to lift my pen, because I can only draw this line. Then I have to lift my pen to draw that line. And if you have to lift your pen at all, it is discontinuous. Okay. The other definition they give here is as soon as there's a gap in the graph. So you see here, there's no gap in the line, no gap in the line, and here, there's a gap in the line right there. You've got a gap. Okay. Okay, the next section is functions and their inverses. Okay, so basically there's a horizontal line test. We did the vertical line test, now we're going to do the horizontal line test. Okay? What the horizontal line test says is draw a horizontal line on a function, or draw a set of horizontal lines. Okay? So let's draw our horizontal lines here quickly. I'm going to draw a couple. There's one. There's another. Okay. So let's count as with the vertical line test, let's count how many times our function crosses the horizontal line. Okay? So here we've got 1, crosses once there, crosses once there, and it crosses once there. Here it crosses the horizontal line twice, crosses the horizontal line twice, crosses the horizontal line twice, and crosses the horizontal line twice. Okay, so what does that tell us? the horizontal line test is a test for inverses. And it basically says if horizontal line, if any horizontal line crosses the function more than one time, the function has no inverse. And if horizontal line crosses function one time only, then function has an inverse. So if any of your horizontal lines cross the function more than once, the function has no inverse. If all the horizontal lines cross the function once, the function has an inverse. So let's check here. Each of our lines crossed only once, so this function has an inverse. Here, the horizontal line crosses more than once, so no inverse. Here, once again, the horizontal line crosses the function more than twice, so no inverse. And it's important that you remember, I didn't do it like that now because I don't have a ruler, but these horizontal lines must be parallel to the x-axis, and for the vertical line test, the vertical lines must be parallel to the y-axis. Okay, just remember that. Otherwise, it's not a proper horizontal line. Okay, so now we've determined whether a function has an inverse or not. The question is, what is an inverse? Okay. An inverse, firstly, the notation. Excuse me. Okay, so the inverse of, so it's denoted like this, the inverse. F to the minus 1 of x is the inverse of f of x. Actually, I don't think that should be there. F inverse is the inverse of f of x. Okay. How do we determine the inverse of f of x? Basically, we just solve. We take our equation y equals f of x equals, say, 3x plus 5. Written otherwise, y equals 3x plus 5. And now, all we're going to do is solve for x. So, excuse me again. Okay, so we're just going to solve for x. And then we will have found the inverse. So let's solve for x. So we're going to take the 5 across. Y minus 5 equals 3x. Then we're going to divide by 3 on both sides. Y minus 5 over 3 is equal to x. Okay? And now that we've solved for x, we've got our inverse. So y minus 5 over 3 is equal to f inverse. And that's it. So just put that on the left. F inverse is equal to y minus 5 over 3. And f inverse is the inverse of f of x. Okay. And that's all there is to finding the inverse. Now just see now, the way they did it in your book is they've done essentially the same thing, except they just swap x and y initially and then solve for y again. So given y equals 3x plus 5, they swap So this is their method of finding the inverse. Swap x and y. So you'd write that x equals 3y plus 5. And then solve for y, which is exactly the same as what we've just done. So you end up with f inverse equals x minus 5 over 3. Okay, I advise that you actually do this where you swap the x and y. Okay, so to find the inverse, take your original function, swap x and y, and then solve for y again. And once you've solved for y, you will have f inverse. And that's all there is to it. Okay. Let's talk about symmetry, which is the last section for this video. Okay. Symmetry. Okay. Okay, so a function or a graph is symmetrical about a line if all points are the same distance from the line. Basically, if the graph, so if graph is a mirror image of itself about a line, then it is symmetrical. So the definitions are a bit difficult to understand. It's way easier if we just do a few examples. Okay, so here's your x-axis and your y-axis, and they gave a graph that looks something like this. Okay, so can you see that if we fold that graph over this line, okay, and this line would be x equals a, if that point is a. Okay, can you see that if you fold this over onto that, it would look exactly the same if we fold it around that line. So this is symmetrical about the line x equals a. Okay. Then we've got, for example, let's draw this line here. Okay. If we fold it about the y-axis, it would look like that. So there's no symmetry about the y-axis. If we fold about the x-axis, we would be there, not symmetrical. But what happens if we draw a line here? So we've got a line here, and this would be the line y equals negative x. Okay, if we fold this graph over around that line, do you see that it would fold over onto itself? Therefore, it's symmetrical about line y equals negative x. And the same goes for example, a graph like this. If we fold it about this line, which is again y equals negative x, do you see that these two would fold onto each other? So if you cut this graph here, or you fold this graph along this line, these lines will lie on top of each other, and therefore it is symmetrical about y equals negative x. Okay, so in this video we've basically discussed all the different properties of graphs. Okay, we've discussed the Cartesian plane / rectangular axis system. Okay, we've discussed ordered pairs, domain and range, relations, functions, continuous and discontinuous functions, inverses, and symmetry. So this is basically all just terminology and properties of functions. And it's very important that you know and understand all this terminology. So it's NB to know and understand all of this terminology before we move on. So make sure that you go through this video nicely, that you understand all of the terminologies. As always, if you've got any questions, feel free to contact me. And yeah, that's the end of this video. In the next video, we're going to start discussing the straight line graph, and yeah, we'll see where we can go from there. But for now, that's it. So thank you very much for watching. Cheers.